Precision agriculture. Precision agriculture, also known as precision farming or smart farming, is a modern approach to agricultural management that utilizes advanced technologies to optimize the efficiency, productivity, and sustainability of agricultural practices. This concept involves the integration of various technologies such as global positioning systems, GPS, geographic information systems, GIS, remote sensing, data analytics, and automation to make data-driven decisions and precisely manage different aspects of farming. Key components and practices of precision agriculture include 1. Remote sensing and imaging. Drones, satellites, and other remote sensing technologies are used to gather data about crop health, soil moisture levels, and other important parameters. This data can help farmers identify areas that require attention and take proactive measures accordingly. 2. Variable rate technology, VRT. VRT enables the application of inputs such as fertilizers, pesticides, and water at variable rates across the field based on the specific needs of different areas. By customizing the application, farmers can avoid waste, save resources, and enhance crop performance. 3. GPS and automation. GPS technology is employed to precisely navigate agricultural machinery, allowing for automated operations. This reduces overlap and optimizes the use of resources while enhancing overall efficiency. 4. Data analytics and decision support systems. Collected data from various sources is processed and analyzed to gain insights into trends, patterns, and potential issues. Decision support systems help farmers make informed choices about planting, irrigation, fertilization, and harvesting. 5. IoT and sensor technology. Internet of Things, IoT devices and sensors are used to monitor real-time conditions in the fields, such as temperature, humidity, and soil quality. These data points assist farmers in responding promptly to changes and ensuring optimal conditions for crops. 6. Precision planting and seeding. Sophisticated planting and seeding equipment ensure precise seed placement and spacing, leading to uniform crop growth and higher yields. Benefits of precision agriculture. 1. Increased efficiency. Precision agriculture reduces waste by targeting resources precisely where they are needed, resulting in cost savings and higher resource use efficiency. 2. Yield optimization. By closely monitoring crop health and tailoring treatments, farmers can maximize yields and achieve better quality crops. 3. Sustainability. Resource management and reduced chemical use contribute to more sustainable agricultural practices, minimizing the impact on the environment. 4. Risk reduction. Data-driven decision-making allows farmers to respond proactively to potential issues, such as pest outbreaks or adverse weather conditions. 5. Data-driven insights. Over time, the collection and analysis of data generate valuable insights that aid in continuous improvement and long-term planning. Overall, precision agriculture represents a significant advancement in farming techniques, helping farmers make informed choices and meet the demands of a growing global population while minimizing environmental impact. Thanks for watching.